Welcome back, protein coders. Let's build some coding muscles. Today, from now onwards, we're gonna study deeply on subsequences via a few questions. So today is our first question. Subsequences with some k. So what question says is you will be given an array and a target integer k. So let's say here it is 8. Okay, we have to find any subsequence with sum equals to this target variable k. Okay, so let's say we have one subsequences here. So 7 comma 1 will be a subsequence with sum 8, so we will return true in this case. And if there is a no subsequence in the array with sum equals to the target variable, then we will return false. Okay, so let's have a subsequence here. So if I start from the back side of the array, so I have two options. Either I can pick the last element or I can skip the last element. Okay, so if I'm starting from the back of the array, right, I have two options, pick or skip. So if I pick the element, so what will happen? My new target variable will be reduced by 5, right, because I have already picked the 5. And if I skip it, then still my target which I want to achieve, the target sum, will remain 8. Okay, so let's go deep into the path of the pick. Okay, so now I have 1, so I can either pick the 1 in my subsequence or I can skip it. So if I pick it, what will happen? Again my target will update and reduce by 1. It will become 2, right? And if I skip it, the target will remain the same as 3. Now again I have this time 2, right? So I can either pick the 2 or I can skip the 2. If I pick the 2, my new target will become 0. What this implies? That we have made the subsequence sum equals to the target. Okay, so we will return true from here itself. Okay, no need to go further. So this is one case. But suppose it can happen that we have went to the last index, okay, index 0, and we have only one element in our array to choose. Okay, so in this case, when we will return true, when if the target value will become equals to the array 0, right, equals to this element, then only we will return true, or else we will return false. Okay, if there is only one element left, if it is not equals to the target, then we will return false. Simple. So these are the two base cases to keep in mind. Okay, now let's quickly write the code for this. So let's create our bool solve function, which will take index, the target k, and array. We are starting from the last index, right? So first base case is if target becomes 0, if k becomes 0, then we will return true, or else if I index reaches 0, we have only one element. So in this case, if target is equals to array 0, right, we will return true. Now for skip case, we will simply decrease I by 1, okay, and call recursively. Simply for take, first we will initialize take with false. Why? Because we can only pick the element if it is less than the target value. Okay, remember this. And at the end we will return skip or take. In either cases, if we have a true value, right, we will return true overall. And let's quickly code this up. Return solve function, bool solve, and it will take index, target k, and array. Let's write both of our base cases. First for skip, second for take. We will take only if array of I is less than equals to k. Take the element, reduce the target, at the end return skip and take. And congratulations, we got time limit exceeded. Now let's see how we're going to memoize our code. If you observe, I takes value from n minus 1 to 0 and k takes value from k to 0. Okay, we have two variables in our recursive function, so we will take a 2D dp vector. Okay, and the dimensions will be n cross k plus 1. Why k plus 1? Because we need k as an index. Okay, so our dp will be of dimension n cross k plus 1. Let's quickly create our dp vector and let's pass it in our function and everywhere else in recursive calls also. At the end we'll store dp of ik, and we will also put the check. If dp of ik is not equals to minus 1, return dp ik. Let's quickly submit this. And yes, we have passed all the test cases. Now let's quickly see how to write tabulation code. For tabulation, let's have our 2D dp vector, okay, which has dimensions for I and target. I from 0 to n, target from 0 to k. Okay, from the first base case, we know if target is 0, then for all index values, the answer will be true. And for second base case, we know if I is 0, then we have all the values marked as false instead of one value, and that one value will be dp of 0 comma array of I when target becomes the array of 0. Okay, we'll mark this as true, and we will just insert a check for out of bound cases. That array of 0 should be less than equals to k. Now we have to fill the rest of the dp vector, and at the end we will have our answer at dp of n minus 1 comma k. Okay, now to fill this we will have two for loops, one for I which go from 1 to n minus 1 and one for target which will go from 1 to k, right? And at the end we will return dp of n minus 1 k. And let's quickly copy our recurrence relation in the for loops, right? Instead of the function calls we will write dp, right? Similar to the steps which we have followed in our all the questions in our dp playlist, right? Here dp of I target equals to skip or take. Simple. Let's quickly code this up. Let's create our 2D dp vector initialized with false initially, and from the base case what we will do, dp of I0 equals to 2, right? And for this for second base case we know dp of 0 comma array 0 equals to true. Now let's write our two for loops and write our recurrence relation as it is, and instead of function calls we will just write dp. That's it. At the end we'll return dp n minus 1 target, oh sorry, k. Let's quickly submit this and let's see. Yes, we have passed all the test cases. Now let's quickly see how we're gonna space optimize our code. If you observe in our tabulation code that whenever we are calculating the skip and take, we are only dependent on the previous row, dp of I minus 1 target or dp of I minus 1 target minus arri. Okay, so I hope you identify this pattern, right? For calculating the current row, we are dependent on the previous row. And our answer at the end, we will return just previous of k. Okay, so let's quickly modify our tabulation code. Let's create the previous vector of size k plus 1 and current also with k plus 1 initialized with false. And for base case, we know that the first value of the previous vector, previous 0, will be true, and also previous of arr of 0 will be true. Okay, and also current of 0 will also be true. Okay, if you see in the table, for every current, the current 0 element will be true, because for target 0 it should be true, right? Now wherever we have dp of I minus 1, we will just write previous, and instead of dp of I we will write current, right? After the inner for loop, we will assign current to previous. At the end, we will return previous k. Let's quickly submit this. And congratulations, we have passed all the test cases. Now let's quickly see about time complexity. For recursive method, we have two options for every element, right? Either pick it or skip it. So we will have the time complexity order of 2 to the power n. For memoization, we are filling the dp vector of size n cross k plus 1. So the time complexity will be of order of n cross k, and space complexity also be of order of n cross k, size of our dp vector. Similarly, in the case of tabulation also. But for the case of space optimized solution, we are only using two vectors, right? Previous vector and current vector of size k plus 1. Okay, so time complexity will remain the same, order of n cross k, but space complexity will become 2 cross k, or order of k, you can say. Okay, so that's all from my side. If you have any queries or suggestions, please mention them into the comment box. You will find the problem and the complete solution link into the description box. Let's meet in some other video. Till then, keep smiling, keep practicing. Thank you.